All right. I'm going to share my screen. Let's see. Okay. All right. Can you all see my screen over here? This one over here? Let me bring up the canvas. All right. Okay, so let's see. All right. So yeah, as promised, this we're going to do a review on the for the midterm. That's going to be available later this week, towards the end on Friday, and then you're going to have the whole weekend to work on that midterm. So today we're going to review some of the material that I sent you over the weekend. We'll take a look at it together, and you know, if you have any questions, we can go over that. And I also sent a couple of UML diagrams that some of the questions here refer to those UML class diagrams. We can go over that as well, and you know, we can also just go over some of the questions on the quiz, or anything that you might that's useful for you. Depending on how we're doing on Friday, again, you don't need to take the exam during lecture, right? We're not going to have the exam during lecture. Instead, we're just going to work on some more material. We're going to probably continue some of the same topics that we began last week, which was, I believe, database connectivity using programming languages, in particular Java. So we'll do some more of that. And in preparation for the topics for next week will be a little more advanced. Some more advanced Java object-oriented mapping with relational databases. It's a very important topic. We'll be preparing for that on Friday, unless you have questions about the midterm. Although some people will already taken the midterm, so it makes no sense for to be answering questions about the midterm, right, on Friday. Yeah, today's last day for any questions you might have. Well, no, up until Thursday, you have time to ask questions. What else? You're still working on the DB6 programming assignment, right, which is due later tonight. And there is no assignment for this week, right, so that you can just focus more on just finishing up the midterm. And what else? Yeah, so that's the plan for this week and next week. Any questions? We get started.
Are we still gonna have class on Friday then?
Yeah, my plan is to cover still on Friday.
Okay.
Not any material that is regarded for the midterm. None of that material is obviously for the midterm, and in preparation for the next half of the semester.
Okay, thanks.
Okay. Let's see. It looks like there's a question on the chat. Let me bring that up. When is the exam due? So it'll be 72 hours. So it'll be available on Friday morning, and then Friday, Saturday, and Sunday. Unless you prefer maybe Saturday, Sunday, and Monday. I don't know if that's preferable, if anybody really cares. Maybe I guess Friday folks are still taking some classes, and they might prefer to have the whole weekend, maybe, I don't know. Yeah, Sunday at midnight. It would be available Friday, you know, early Friday all the way to Sunday at midnight. Or it could be early Saturday and all the way till Monday at midnight. I don't know, whatever you prefer. The material that will be covered is up until and including stored procedures. Right, so all the material that we've seen so far, right, is everything up until the stored procedures. No triggers, right, because we just covered that late last week. But definitely functions, definitely store procedures, but no triggers. So if we prefer the one that goes till Monday, is there any way we can request that? I'll make a poll maybe on Piazza and see what folks prefer. If they prefer to do it maybe Friday to Sunday or maybe Saturday to Monday, I don't know. I'll do a poll, see how everybody's doing. I don't know that it would matter that much. I guess it give you maybe an extra day, perhaps. All right, let's see. Let's see. Is this sharing? You are sharing the screen. I'm sharing the screen, and how would I show that here? Stop sharing. How would I show that here? Let's see. I'm trying to share my screen from my iPad so that I can draw and we can work on the problems together. Let me try it again. It just worked 2 seconds ago. I don't know why it's not working now. Screen sharing. I allow it, right? New share. No. You are. Oh, maybe because I'm sharing screen. Let me try that. I'm going to stop my screen share here, and then I'm going to try and share from my iPad. Start broadcast. Let's see if that works. Start broadcast. Where is it? Is it different? No. Oh, maybe I'm supposed to allow it over here. Let me try it again. Share. Start. Huh, interesting. Why is it not sharing? Materials worked before. Why is it not working now? Multiple events. Live. Sorry about this. So I'm supposed to be able to share my screen from my iPad. It worked when I tested it, and now it's not working. Multiple participants. Stop sharing. Let me go back and take a look at the. Let me just send my invitation again. Context, participants, invite, copy invitation link. Let me send it back to myself again. And I'm going to reply. Send. Join meeting. Okay, you have logged into another device. Your polling session is active. Okay. This meeting is being recorded. Continue. Cancel. Okay, can you still see me? Everybody still there? Did I lose anybody?
Yeah, we can still hear you.
Okay, good. All right, let me try sharing now. Share content, screen. Before that, I'm going to share content, screen, start broadcast. Did it work? All right, I think it worked, right? Can you all see my iPad?
Yeah.
All right, here's the midterm. All right. Okay. Right. So so I'm guessing you've all seen this this content, right? I sent it earlier in the week. Actually, late last week. Actually, I sent it, right. And these are just a few example questions from several midterms. I've just pulled them all together in one single document, and I thought maybe we could go over it together. Some of these are very easy. Some of them are a little more challenging, and then we can also go over some of the questions in the quizzes, right? If you have questions there. All right. So consider the following schema. This first question. It says we have the table order, right? And we have a few fields: customer, order date, and order price. And it's asking us, right? They want the sum of all the orders per customer. Okay. And they give us several options, right? So the sum of all orders, right? So we're everywhere, right? We're seeing for things where we can presumably find the aggregate function sum, right? And then the sum of all orders. So the sum of whatever that is, right? And presumably you have to be able to deduce that obviously what we want to add are the prices, right? Obviously, it would make no sense to add up the dates, right? It would make no sense to add up the customer, right? But we're adding up the prices, okay? And so any of these select statements that has some order price, right? You should all consider any of these, right? So any of these should have order price, right? So they all have it. So that doesn't give us any clue on which one is this here, right? The other clue that they give us is that it's a per customer. So that means that we need to group for when the customer is the same, right? So notice the field customer, meaning we are grouping by this field, right? So we need to look for all the ones that we have a group by customer. So that's one. That's another one. Well, not this one. That's no good, right? Because we are grouping by order price. And this one is grouping by order date. So that's not good either, right? So it has to be between these two. Okay. And well, this one has, it looks like it has a missing comma there, but that was not intentional, right? I'm not going to intentionally put a syntax error for you, right? So you should ignore any syntax errors. If we're not going to deliberately try to fool you into, oh, there was a missing comma or anything like that. But really what distinguishes between these two, right, is the fact that here we both have customer, right? So that's the same for both. And we have to ask ourselves, well, is that okay, right? Well, we're grouping by customer, so that means that any of the fields that are in the group clause can appear in the select clause. Okay, so customer is okay, right? But notice that this one also adds the order date, right? And that's not in the group by, right? So that's a no-no, right? That's syntactically incorrect. So we should discard that one. So definitely the right answer is the first one. Okay, that makes sense. All right. Let's see the next one. Some of these are repeat themselves, right? It gives us a chance to practice them. So the next one says, consider the following schema. It says you have a student, right? With the student ID, it has the graduation year. It has a mid ID, and all of these somewhere in the instructions probably said that anything that is bold, right, was a primary key, and anything that was italic or underlined was a foreign key. Let's see, so it looks like there's questions on the chat. Let me bring that up. So who would prefer? Okay, so nothing on the chat. All right. So yeah, so this probably is a foreign key that points to that, right? Okay. Now the way we cover that in the new exams and quizzes is that we will explicitly put a PK for the primary key, And we will explicitly put here a foreign key, just to let you know that that is indeed a foreign key, and that the name of the foreign key matches the primary key that it's referencing, right? So usually that you'll find that in the instructions, but I think I've been pretty consistent at following that that nomenclature. Okay. So anyway, so with that been said, the question is, what are the min and max graduation year, right, per major? Okay. So the per major should give you a clue that we want to group by major, right? Somewhere in there, something about major, right? Major, the J, sorry. English is not my first language. But we can group the major, presumably, is this primary key that we can group by, right? Or maybe this primary key over here, foreign key, right? So let's see what we're trying to do here. Let's see. Also notice that we have min and max. So those are very well known aggregation functions when you are grouping tables, right? Rows, and it's the min and max on the graduation year. So it looks like all our options have the min and max, right? Graduation year, so that's good, right? And min and max, so they'll have that. Okay, how about this one? That's this one as well. Okay, so that one's good. So they all seem to be correct on all these accounts, right? So that doesn't help us much, right? So let's keep going. Let's see. We also looks like we are grouping by the major. So let's see where we can find things that we are grouping by the major. Let's see. Well, here, okay. So that's grouping by this one over here, right? By that one. Whereas this one is grouping by the year. That makes no sense, right? We don't want to group by the graduation year. We either want to group by the major ID here or the foreign key over here. Okay, so that's no good. So that one's no good. This one seems to have a from, then a where, a couple of ands, right? And then a group by graduation year. So that's no good either, right? So that's a discard that one. All right. So the last two that we might want to consider are this one, either A here or D here, right? So which one? Oops. All right. And let's see if we can find something wrong with either one of them. Let's see. So this one, they're both seems to be grouping by major ID, so that's promising. And because we're grouping by major ID, we can include it in the select clause. So they both are good, right? So both are good. Now I guess the only difference between these two is that this one's also including the major name, right? And again, because the major name is not in the group by, right? This is syntactically wrong. We cannot include any fields that only the fields that we either group by or that we have the aggregation functions are allowed in the select statement when we're grouping by. Okay, so here we're just going to keep A again, right? All right, so how about number 3? So these are just lots and lots of different grouping examples, right? So this one has an order and a product, and they seem to have 2 primary keys, and then this one is a foreign key that references the other primary key, right? So let's oops, can I erase this? Can I erase this? There we go. Can I erase that? Okay. All right, so let's keep going. And so the what we're trying to answer here is how many products, how many orders. So that how many usually is a count, right? We want to count how many, and also it's per product, right? So presumably we want to group by the product, okay? And the product, it would be either maybe the product ID here for the product, right? Or maybe the product ID in the order, okay? Depends on what is that we're looking for. And so we want to count how many orders, right? So we want to count these guys, we want to count, right? And typically when we count any number of records, usually what we count is the primary key. That's what we count, because we want to guarantee that we count things that are not null, right? Now we don't know about order dates or anything else here, whether they're null or not null. We know that the primary key definitely is not null, right? So we're going to count that primary key. So here we are. Looks like we're grouping by the product ID. That's promising, and we're counting the order ID. So that's also promising. Okay. How about this one? Here we're counting the products. That's not what we want, right? We want to count the orders, right? So that's no good. That's not that one. This one we are counting the order, so that's promising. We are grouping by the product ID. That's also promising. Okay, and we are including that product ID in here. That's also okay, right? But we have the order dates. That's no good, right? We can't have non-grouping fields in the select clause, right? So that's not good. This one we're grouping by order dates. So that's not good either, right? So definitely we're going to stick to the first one, A. Probably these in the order that I copied them, all the right answers are going to be A, I'm guessing. Here's a one that's maybe a little more involved, right? We are now going to consider 3 tables at once, right? We started grouping by 1 table, then 2 tables, and now we're going to take a look at 3 different tables, right? And this is taken straight from the university examples that we've been using for the last month or two, right? So we have an enrollment, and that has 2 foreign keys. These are supposed to be 2 foreign keys. This SCID is referencing the section. This is referencing the section, and the SID is referencing the students. Right. So this is straight from the database we've been using, right, as an example for the last couple months. And so the question is the following query legal? Is the following query legal? Right. All right, so what do we have here? So we have select this first one. Let's see this first one. It looks like we have a select statement. Q. What's Q? Q seems to be this over here, right? Looks like it's the name of this view, right? This inline view. It's like a table, right? It's giving it the name of some table. That's some virtual table. It's not a real table. It's actually an inner select statement, right? That we are calling Q. So that's okay. This one's good. This one's okay. And what are we doing in this inner Q? So we're selecting the E, SID, SCID. We are counting EID, and we are grouping by SCID, so that's okay, right? So because we're grouping by SCID, this one's okay. That's okay. And we're counting from the enrollment table, the EID. That's also okay. And we're having a rename, so that's no problem there. From E, where grade is A, so that looks okay. And oh, what do we have here? We have what do we have there? That's an aggregation function on the where clause, right? That's no good, right? We can't have an aggregation function in the where clause. Remember the order of the group by, right, is that you run the where clause, then you run the group by, and then you run the select, right, in that order. Okay, and so that's one of the reasons of some of the limitations that the group by has, right? That it has to occur in that order. We first have to identify what the records are before, right, we can do any aggregation. Right? We can't aggregate if we haven't identified what the records are first, right? So that's no good. So this is no good. Well, let's keep going. Oh, true or false? Is the statement legal? No, it's not legal. False. Okay. All right. So all right. So this question is about data access objects. This is about a topic that we just started late last week, and so you're not gonna have any questions about data access object in this midterm, but nevertheless we can quickly go over that real quick. So usually we create a data access object for every table, right? We said that already last week, right? Which of the following best defines the data access object? Design pattern. Yeah, these are all design patterns that provides an interface that encapsulates interactions with the database. That looks right. A design pattern that automatically maps an object. That's not it, right? That's an ORM, which we'll discuss that topic next week. A design pattern that controls access privileges. No. An object for a record. No. Okay, so it's this one, right? Question 7, what are the design patterns? We haven't talked about that, but definitely the singleton pattern. It is often a good idea to have multiple instances of the same data access. No, actually, no, that's not good. Okay, let's go back to where we were. Oh, this is functional dependencies. We haven't talked about functional dependencies. We'll be covering functional dependencies also in the next week or so. So I'm going to skip over the functional dependencies questions. Functional dependencies, functional dependencies, functional dependencies. Okay, here's a UML diagram. And this UML diagram is, I sent you this UML diagram, and I have it, let me share that. Let me see where I have it. I believe it's right here. It's this one. And which database are you talking about? Okay, so referring to the UML class diagram in the handout, label school database, which is this one right here, this school database. Okay, so you have a department, you have a course, section, enrollment. I did mention that there was a typo here, right? That this actually, can I share this? How do I share this? Print layouts. I guess I can't. Anyway, there's a typo here. There's a typo I mentioned in the Piazza post that these should be inverted. This should be star. The one here should be star, and the star should be a 1. Those should be flipped, right? I did mention. I sent out a post. Anyway, it's basically the database that that we've been using for the last couple months, right? Where we have a department, we have courses, sections, enrollment, students, and zip code, right? So the question is, select the statement that best implements the following query. So the query is, which students got, right, the highest grade in a course titled 5200 in the semester of spring 2015. Okay, right. So list the student's ID, first name, last name, and final grade. Okay. All right. So we need to identify a couple of things, right? We need to identify the highest grade. So somewhere we need to look for something like a max, right? Like max grade, something like that, right? And we need to filter and make sure that the title is CS3200. Right, so there must be some kind of like a where the title is equal to CS5200. If I could type, it doesn't erase. Why is the eraser not working? All right, never mind. So where the 5200 and the spring semester is 2550. Okay. Okay. So let's see. Let's look at this one, right? Let's look at this one. So it says like max grade. So it looks like this is it's an embedded query, right? So it's an inline view where we are identifying some student. We're trying to retrieve a student, right? And the information about that student, and where the grade of the student, right, is equal to some max. The grade of the student. So this is trying to match the grade in the student, and but it looks like the student doesn't have a grade, right? The student doesn't have a grade. Oh, it does. Yes, they do. Right. In the one that's oh, I see. The enrollment has a grade, and also the student has a grade. Oh, okay. All right. So yeah, so it would be okay. That query would be okay, right? Because we have a student, the grade in the student. That's okay. All right. So let's leave it. That's okay. Let's leave that. Last name, first name, and so okay. And so S grade is equal to the max grade as we do what? As we group. Looks like we're not grouping anything, right? It doesn't look like we're grouping. That means that we are grouping an entire thing, right? The whole we're aggregating an entire table, right? Or whatever all the joins of that result set is, right? And we're filtering. How are we filtering? We're filtering the course title is CS3200. The enrollment semester is 2015. That looks promising. It looks like these are joins, right? They're just joining the enrollment that points to the section, and then the section points to the course, right? So we're filtering and saying, okay, what's this enrollment, these sections, these courses that match this this semester and this title. So this looks promising, right? And then the resulting of that max, we are then finding what student that is. Okay, so this one's promising. Let's look at this next one. So this one has the same outer select statement. This has the same outer select statement. Actually, I think they all do, right? They all have the same outer select statement. Okay. So the only thing that is different, right, is the inner grouping, right? Let's see. So let's keep looking. Let's see if we can find something wrong with this one. So select, max, grade, enrollment. So it's okay, same thing, right? We're retrieving the same three tables, and we are doing the join. We're doing the join. We're doing the filtering. We're doing the filtering. Oh, okay. No, I'm sorry. This one is grouping. This one is grouping, and this one is not. This was not grouping. Okay, so this is kind of like averaging out or maxing out everything and not grouping it by section or whatnot, right? Now the problem with grouping here is that it would not return a single value. It wouldn't return a single value, right? Group by would return multiple values grouped by the section ID. See that? And so that would not work because here we're trying to compare it. We're trying to compare it against a single value, right? So this would be invalid because this is returning multiple values as opposed to just one grade that we can compare. Whereas this one, right, is indeed grouping the entire result set and returning a single value that we can then compare against the grade over here, right? So this one's more promising than that one. Okay, so let's continue. What's this doing? Yeah, so this is trying to do the same thing. It's like max grade. It's going from enrollment to section, and it's doing joining the sections and the enrollments. And then here's kind of like some weird join, right? That looks like it's trying to join, but that's not going to work, right? You know, this should be in the from clause, not over here. So this is no good, right? There should be comma course, right? Right. So this was no good. And how about this one? This is kind of the same thing. It has the same problem. We have two of the tables. We're joining the two of the tables. Enrollment with, okay, that's not how you do a join, right? So that's no good either, right? So definitely none of these three. So we're gonna go with this one right here. This one right here. Okay, so no, and no. Okay. All right, so now let's look at the airline database. And the airline database, let's see, the airline database is over here. The airline database, let's take a look at it real quick. We have an airline, right, that has a primary key. It has I can't say this, can I? No. It has a name of the airline. It has who's the operator, who operates the airline. We have the flight that has a primary key, and also notice that it has a foreign key that points to the airline. Oops. A foreign key that points to the airline, It has the type of flight, the source, where it's flying from, and it also has a destination string, right? That's it's flying to. How long the flight is. It also has a reservation, right? That also has a primary key and a foreign key to the flight, right? So this is a reservation for a flight. Also notice that there's a booking agent, right? There's also the type of reservation. And then we have ticket information. This ticket information seems to be a mapping. See that? We have a one-to-many at the top, and then we have a many-to-one at the bottom. So that's definitely a mapping. It's mapping what? It's mapping reservation ID. See RID here. It's a foreign key, and then a passenger ID. So this is a ticket information, says that this ticket belongs to this passenger. Also, the price has a date of boarding and the type. And notice down below we have a passenger. Passenger has a primary key, has first, last, age of the passenger, the email, contact string, and then a foreign key to the cuisine, right? What food they want to eat. Okay. Anyway, so the question is, referencing the UML diagram, select the statement below that best implements the following query. So which reservations of flights going to New York, right, have a total cost of $400 or more dollars? Okay, so when you would say a total cost, that sounds like a sum, right? We want to add up something, and then where the total cost is of a reservation is the sum of all the prices of all the tickets in that reservation. So a reservation actually can have multiple people in the reservation, right? So say my whole family is flying together, right? We might have the same reservation number, right, on the same flight. Okay, so that's where reservation comes in, right? Reservation, right, can have many tickets, right? One reservation can have many ticket information that maps to the passengers. So many passengers can be in the same reservation. Okay. All right. So let's see. And also we want to be able to say, which reservations of flight going to New York. Where is that information? So that information is in the destination, right? The destination is in the flight right here. My destination. So we need to join that flight, and where we're saying destination is equal to New York, right? And have a total cost of $400. Total cost of $400. So where's the cost? So the cost is part of where? Let's see. Not in the airline, not in the flight. The flight doesn't have cost. Reservation doesn't have cost. Ticket. So ticket information has price. Right, has price. So we need to join the ticket information. We need to join it with the reservation with the flight, right? Where the flight is going to New York. Right, so from the flight, we're going to say where destination is equal to New York. We're going to join it with a reservation, right, with the foreign key, primary key here. We're going to join it with the ticket information, and then we're going to try and add up all those prices. Right, so that's going to give us all the tickets, all the prices. And we're going to add up those prices. Now, grouped by what, though? Grouped by what? Where the total costs, so the total cost of reservation is the sum of all the prices of all the tickets in the reservation. So it looks like we want to group, right, by the reservation. So a reservation has a whole bunch of tickets, which we want to add up, right, into one single thing. We want to aggregate all those costs, all those prices of all the tickets in a reservation. So we want to group by reservation. Okay. All right. So knowing this, let's see what we got. All right. So here are the three tables of interest, right? The reservation, the flight, and the ticket information. Okay. And starting with the flight, we can get to the reservation. We can filter the destination with New York. That's promising, and we can join the reservation with the ticket information, right? So these are the two joins that are joining the three tables, right? Flight, reservation, and ticket information, right? So we're joining all those three tables. And we are grouping by the reservation, right? And notice that we are using a halving, right? Halving we covered in one of the last lectures, right? That allows you to have averages and sums and mins and max and aggregation functions in the halving, right? So having total cost 400. So total cost would be what? Would be this total cost, which is the sum over here. So this is promising. This is promising. Let's take a look at the next one. Okay. All right. So what about this one? Okay. So this is the same thing, right? We're using the same exact three tables. Here are the two joins that we need. Right. Those are the two joins. We are filtering by destination equal to New York. And we are grouping by reservation ID. That looks also promising. The only difference between these two is that we're doing the aggregation up here. That's also okay, right? And then we are doing this greater than or equal to 400, right? What's that all about, right? You can't have comparisons, right? You can't have comparisons in the select clause. You can have comparisons in the where clause, right, but not in the select clause, right? So that's not good. So let's keep going, right? Let's see, what do we have here? We have the same three tables, right? And here are the two joins, right, that are going from the flight. Okay, was the join here correct? Yes, the join here is correct, right? This one's okay. And this one looks like it's okay. Okay, the two joins, we have the same destination. All right, so what's the difference between this one and that one? Okay, so this one doesn't have the group by, right? So this does not have the group by, so it's no good. Okay, and what do we have here? We have same thing, three tables, right? We have the two joins. We have the destination is good, right? Again, we don't have a group by, so that's not good. So basically, we're left over with we're basically left. So this one's no good either, right? Because we have that here, right? That's no good. All right, so we're just left with this one. So we'll go with the first one. Okay. All right, let's keep going. Lazy loading, that's ORM, which we'll start covering next week. Lazy loading, that's also ORMs. We'll cover next week. All right, so here's a normalization, question about normalization. And this one says, considering the following schema, customers, right, that has the following fields, right, first name, last name, and telephone, right? Put this over here. There we go. Okay. Right, so we have customers, right, with the fields CID, first name, last name, and telephone. So it says, if each student can have multiple telephones, which of the following solutions would not, right, break first normal form? First normal form. So remember, there was three normal forms, right? The first one was making sure that there was that the only dependency of the fields, right, that there was a dependency on the primary key, right? And we were trying to avoid redundancy where you might have multiple values stored in the same field, maybe comma separator or things like that, or multiple records, right, that would copy the same content multiple times. We wanted to avoid that. And then usually the solution was always, you know, splitting that big table into multiple tables, right? And we call that normalization, right? So let's look at this. So basically, we want to be able to have customers have multiple telephone numbers, right? What if you had phone 1, phone 2, 3, 4, and so on and so forth? Very, very similar to the example in one of the slides, right? So how do you fix that? And if you remember, the fix was to split, right? Where split the two tables, split the one table into multiple tables, where we have a separate table that we store all the telephones for that particular customer or that person, right? We said that a bad solution would be to have telephones contained in a comma-separated list, right? Where this is now plural, and presumably we will now storing multiple telephones in one field. That's a bad solution. Or separate records, meaning you're going to have multiple records of the same student or same customer, and the only difference will be that the telephone will be different, right? But the same customer one, repeated multiple times, the same data over and over. That's no good either. Or the other solution would be to have multiple columns, one for each telephone. Again, that's also a bad idea, right? So anyway, the solution would be to just separate it into multiple tables. So definitely you should expect normalization questions, right? That about first normal form, second normal form, third normal form, right? Here's another question on normalization. So yeah, I think we did cover some of this, right? So we said consider the following schema with composite keys, course ID, semester, right? And says with functional dependency, right? Course name, course ID. And we didn't cover functional dependencies formally, although we did talk about dependencies in general, that fields that depended on each other, right, was bad, right? That we did say that all the fields should only depend on the primary keys, right, or the composite keys, right, but never should they depend on each other, right? And that they should not only depend on the key, they should depend on the whole key, right? If you have a composite key, then you should not have the case where the value of a field is entirely determined by half the key, right, or by some fields in the key, right? That if you have multiple keys, it should be determined by the whole key. So this is what it's trying to say here, right? Is that course name is fully determined by the course ID. Right? If you know the course ID, then you know the course name, right? So this one, there's a dependency between this one and this one, meaning there's no dependency between the course name and the semester, meaning you can have in multiple semesters, you can have the same course, right? I think this is taken straight from the slides as well. Right, and so this one we say that this is breaking, or it's violating a second normal form, right? So the term that folks use oftentimes is it's breaking first normal form or second normal form or third normal form. It's breaking, meaning it's violating, or it doesn't adhere to that normalization. So yeah, so it's this is a classical second normal form violation, right? So we're going to go with second normal form, meaning when your second normal form is especially important when we are looking at the composite keys, right, where the keys have more than one field, right? And we're looking for the other fields, the non-key fields, right, making sure that they depend on the whole key, right? That depend not only on partial key, right? Whereas third normal form says nothing but the key, right? Remember. So first normal form says the key, right? Second normal form, the whole key, right? And nothing but the key, right? So first normal, second normal form. Okay. Okay, so let's see, what else do we have here? Right, so this one was giving us another table, right? We have course, we have it's also, again, it's a composite key. We have the professor, we have the date of birth. I think this example is also taken almost verbatim from the slides, right? And we're saying that there's a dependency between the professor and the date, meaning the professor can only have one date of birth, right? Meaning that if you know the professor, right, then it fully identifies what the date of birth is. It cannot be anything other than their particular date of birth, right? So if you know the professor, you know date of birth. Anyway, if you're going to store in the database anyway, right, you're going to know, meaning there's a dependency between these two. And we said that that's a no-no. Again, it's breaking what? It's breaking this, right? Nothing but the key. The dependency should be, all the fields should depend on the key, on the whole key, and nothing but the key, right? But here we have two fields that are dependent on each other, right? That there's a dependency between these two fields, and that's a no-no, right? That's breaking, or it's violating third normal form. So this question says, select all normal forms this schema fulfills. So it fulfills first normal form, right? Does it fulfill second normal form? Well, it doesn't, right? Because it doesn't even depend on the whole key, right? So no, it doesn't depend. So wait, I'm sorry. So it does not. Yeah, it doesn't fulfill second normal form. It doesn't fulfill third normal form either, right? Because it should depend on nothing but the key. Okay, right? So really the only one that it fulfills is first normal form. Right. So question 19: consider the following schema with composite keys, primary, course ID and semester. And this is dependency between course name and course ID. So there's a dependency between course name and course ID. And the question is, how would you fix it? What would be a better alternative, right? How would you fix it? So let's see. One way to fix it, again, usually the solution when it breaks a normalization. Well, first of all, you need to understand that this is a normalization question. Notice that nowhere do we ask you about normalization, right? You first have to identify the fact that this is breaking second normal form, right? It's breaking second normal form, okay? It breaks second normal form. And the way we usually fix that is that we break it into multiple tables, and then we join the two tables, right? Having a foreign key, primary key refer to each other. Okay, so let's look at the first one. So notice that they all, looks like the three options that they give us, they all break up into multiple tables, right? So we need to now see, well, which one makes sense, right? Which one makes most sense? So let's see. We want to basically, this course name, we want to move it over to a separate table. Okay, notice that seats is okay, right? It depends on both. Meaning for a given combination of a course, and a semester, you'll have one number of seats available, right? In a different semester, for the same course, you might have a different number of seats, which is perfectly fine, right? But the course name is always going to be the same, right? That's why the dependency between these two. No matter what the semester is, the name of the course is not going to change. It's the same course name, right? So we don't want that. We want to have a separate table where we can have all the information about the course. So that's what we're doing here, right? In all the cases, we create a brand new courses table. There it is, right? In all cases, we do that, which is perfect, right? We have the course name, and we only leave in the courses in the original table, right? We call it maybe courses seats. Well, the name of the tables doesn't really matter. We leave the seats, right, which is indeed dependent on both of them. Okay, and the course is separate. So this looks promising. Presumably, this is a foreign key that references that course ID, which is good. That's fine. What about this one over here? And notice that in this case, we kind of move the semester away from the previous table. That's kind of weird, right? It's breaking up a composite key. We're breaking up the composite key to in a separate table. Is that even a key? Yeah, and that doesn't look right. Right? How about this one? We seem to have again split the semester. Seems to have split the semester, into its own table. I think that's an overkill, and now we kind of lost the fact that the seats are different, right? For every combination of course and semester, we kind of lost that information, right? Before, right? We knew that there you have different seats for the same course for different semesters. We lost that from the original, right? So that this instead of saying that it's trying to relate a particular course and a seat, right? That's kind of saying like for the same course, you're always going to have the same seat. That makes no sense, right? So yeah, so that's not good. So we're going to keep this this first one, right? Okay, so here's another one that looks very similar to the one before. We have consider the following schema. Follow the schema with a composite key, employee, and skill. Again, this one I think is straight from the slides, and we have a relationship between employee and location. Right, so employee is location over here. Again, there's a dependency between two fields. One of them is a composite as a key, and the other one is a non-key. And we already know that it's a bad idea to have any dependencies between partial keys, right, and non-keys, right? So again, this is breaking second form. And the fix usually is that we split it into multiple tables, which we did over here. We split the employee into a separate table, right, so that we can have the information about the employee, right, employee name, their location, the date of birth, everything that has to do with the employee is there, right? And then we have just a reference between the employee name and the skill, okay? So yeah, so it's the same thing as before, right? We're going to go with the first option. Okay, so let's see. What's this about? This one says, now consider the following schema. We have 3 tables: passenger, reservation, and ticket. This is probably taken from the airline database, right? But displayed in this format. It says select the statement. All right, so let's try to understand this. So we have ticket seems to be a mapping function, right? That is trying to map passenger, map it to a reservation, right? So that's okay. And the ticket has information about price and date, and the reservation has information about the booking agent, who made the reservation, whereas the passenger information is in the passenger table. So here's the questions: is all the names we want all the names of senior passengers, right, booked by Alex. So all the names of senior passengers booked by Alex. So this looks like a trivial select statement with a couple of where clauses and maybe joining this information, right? So all the names of senior passengers. So the names, where are the names? The names are in the passenger table, and the booking agent is in the reservation. So we need to join these two, right? We need to join the passenger and the reservation. Notice that there's no way to get from the reservation to the passenger, right? The only way to get between the two is through the ticket, right? So we need to join all 3, right? We need to make this one equal to that one, and then this one equal to that one, these 2, right? We're going to need to join these 2, right? So let's do that. So there it is. We have the 3 tables. Very good. And these are the joins: passenger to ticket, and then ticket to reservation. So that's promising. And we're filtering the passengers who are seniors, right? Greater than, age is greater than or equal to 65 years old. And the booking agent is Alex. So that looks promising, right? And we're printing the passenger name. Okay, good. That looks good. Let's look at these 2 other ones, right? So we're still same thing, right? We're going to try and join those 3 tables. And so the joins is wrong, right? Notice that we were trying to join the passenger ID with the ticket ID. That makes no sense, right? And the ticket ID with the reservation ID, that makes no sense. Okay, so that's no good. Probably something similar here. Notice that we only have 2 tables here. We have only 2 tables. And notice that the join is weird, right? Even though the fields are correct, this can't live here, right? This has to be in the from clause, not in the where clause, right? So that's no good either, right? No good. So this one, again, same thing, right? We're trying to join only 2 tables. There's no way of getting from between the passenger and the reservation. The only way to get between the 2 is through the ticket, okay? So this is okay, right? But the other one's wrong. So that's not good. So we're gonna keep the first one. We're gonna keep the first one, first answer. Okay. All right. So let's take a look at this. Other says we have three tables. Any questions so far? We've gone through 22, 21 questions. Any questions? Is this helpful? Right, these are type of questions that you can hopefully these are the type of questions you're going to get on the exam. So okay, so we have three tables. We have student table, section table, enrollment. Looks like again, right? There's notice that there's no relationship between the two, right? The only way to communicate between these two is through the enrollment, right? Because the enrollment has foreign keys to both, right? To the student and the section, right? So there's a mapping table of enrollment that maps these two. Okay, so the question is, we want all the student names, section, that section, and the semester fall. Very similar to the previous example, right? So we need to be able to join all three tables, right? Because the name lives in the student table, and the section, right, lives in the name of the section lives here. But there's no way to get between the two, between the two. That's why we need to go through the enrollments table, right? And the semester is also in the enrollment. So definitely we need to join all three. Okay, so let's see. There's three tables there, very good. Let's see if we can find real quick ones that don't have three tables. This one's three tables, so that's also considerable. It doesn't have three tables, so I'm not even going to look at that. Okay, and this one only has two tables, so again, I'm not even going to consider that one. All right, so it's between these two. Now, usually most of my questions are going to be like this, right? There's going to be two questions that are obviously wrong, right? And then two of them, the remaining two, are the ones where you need to just look a little closer, right? And say, okay, well, what's the difference between the two? And what gives away this answer? You know, which one is the right one or the wrong one? Right. So notice that they both are filtering by the name of the semester and the name of the section. So that's good, right? They both do that. That's good. Let's look at the joins. So here are the joins, right? Here we're joining the student with the enrollment. That's good. That's correct. And then the enrollment with the section. That is correct, right? So yeah, we can join between the two, right? We're going from student to enrollment, and then from enrollment back to section. Okay, so that's good. What about over here? We're doing joining student with the enrollment ID. That makes no sense, right? And then the enrollment ID with the section ID. That makes no sense. So this is no good, right? So we're going to keep the first one. All right, so this one, it has three tables, probably similar to the previous question, again, just to practice. It looks like we have a stock, we have a portfolio, and it looks like a transaction is mapping portfolios to stocks, right? So transaction seems to be some kind of mapping table between the two. And there doesn't seem to be any way of getting between the two, right? There's no navigating between stocks and portfolios, only through transactions. So the question is that all the technology stocks owned by John, right? All right, so technology stock. So probably that might be something about a type, right? The type of the stock, probably. And the owned by John, probably it has to be some kind of portfolio that has an owner, right? That's equal to John. Okay, so let's take a look at this. So so it looks like we're going to need to, the technology stock is a type of the stock is over here, and the owner, John, is down here, but there's no way of relating these two. There's no way to relate these two. We have to go through the transaction, right? And so we need to be able to join all three. Let's look at real quick the ones that we are we're considering all three. So that one's considerable, right? How about this one? Also has a three tables that we need to join. What about this one over here? We're only joining two tables. That makes no sense, right? Because there's no way to go from stocks to portfolio. So that's no good, right? And this one is also stack the portfolios. Again, there's no way to get from one to the others and not even consider it. So basically it's between these two, right? And the type, right? Both are filtering the type of the stock as being technology and the owner being John. So those are both worthy to consider. So basically, probably the difference is in the where clause. Let's take a look at the where clause. Again, here we are joining the stocks with the transactions, right? With the correct foreign keys, right? So stock, right, with transaction right here, and so that's good. And then we're joining the transaction with the portfolio, right? So transaction with the portfolio, these two over here. So that's good, right? So that's correct. Okay, so that's promising. Here, notice that this is wrong, right? We're going from the stock to the transaction. There is no mapping between these two, right? There's no foreign key equal to primary key between any of these two, so that's no good. And here the same thing, right? There's no communication between transactions and portfolio, so that's no good, right? So we're left with just this one. We want to keep that one right there, the first one. Okay. How about this one? It says consider the schema below, right? That we say that a quiz question cannot exist without a corresponding quiz. A quiz question cannot exist without a corresponding quiz. So presumably there's kind of a dependency here, right, of existence, right? That a records of questions, right, need to exist only if a corresponding quiz exists. Meaning that if somehow the quiz for which you existed at some point doesn't exist anymore, well then you can't exist either, right? So it says, and this is a schema, right? And the schema is that you have a quiz, right, that has a primary key, and you have a question that also has a primary key, but the question has a foreign key that is referencing the quiz. See that? Notice that the primary key and the foreign key have the same name. Okay, so there's basically there's a one-to-many relationship between the two, right? There's a one-to-many relationship, and not only that, right? There's a life cycle dependency, right? One cannot exist without the other. The quiz question cannot exist, right? The question cannot exist without the quiz. So typically the way we represent that is that if you have here the quiz, and here you have so there's the quiz, there's the question, right? We say that there's a one-to-many, but then if additionally we want to say that one cannot exist with the other, that there's a dependency between the two, the way we usually cover that is by saying that there's a composition dependency between the two, right? And the way we document that is that we add this diamond, right, going from the one to the many. Okay, that there's a life cycle dependency that if you remove the quiz, you have to remove the question. The questions cannot exist without the quiz. Okay, so the question says, well, select the best equivalent UML diagram that represents this relationship between the two. And indeed, we have here. Let's see, what do we have here? So this one looks promising, right? Because it has the dependency, the life cycle dependency between the quiz and the question. Notice that also the diamond, the filled-in diamond, this already is implicit that this is a one-to-many, right? The diamond always goes on the one side, and the line goes on the many side. It's implicit, right? There's no need to add it. Nevertheless, we usually add it just for clarity. Now this one over here, we do have the one-to-many, right? Because an empty diamond also means that there's a one-to-many relationship, right? And one on the diamond side and the many on the not diamond side, right? But this one breaks the life cycle dependency that we were looking earlier, right? This is a composition, which looks like it's what we want, whereas this is an aggregation, right? And this says that there is no life. Aggregation means that there's no life dependency, meaning that if you remove a quiz, you can still keep the question. Whereas composition says that if you remove the quiz, the corresponding questions also have to go. Okay, so aggregation for the aggregation question, we might have said, questions can exist. Even if you remove the quiz, the questions can linger on. Maybe you add the questions maybe to another quiz, right? That would be totally fine. But then that would be represented by an aggregation and not a composition, right? What do we have here? We also have a composition, right? That's also a composition. And there's a one-to-many like that. But that's not what we have. We have a quiz. We have a quiz having many. We have one quiz having many questions. We don't have one question having many quizzes, right? So this is wrong, definitely wrong. And this one is what? What is that? That's inheritance, right? That's inheritance, right? It establishes an is a relationship, right? It does not establish a one-to-many relationship or many-to-many relationship, right? It establishes a completely different relationship, right? Is a relationship, which is not what we're looking for, right? So that's not. So definitely between these two, right? Between these two, but we know that because what we're looking for is not aggregation, right? We're looking for composition, right? So we're going to stick to the first one. Okay. All right, so let's look at this one. So you're going to get several questions where, we give you a schema and you need to be able to represent it as a UML diagram, or vice versa. We give you a UML diagram, right? And then you tell me whether the schema is correct, right? So the schema can be displayed either in the form of an actual schema like that. It could be a create statement, right? A SQL create statement, or it could be an actual table. An actual table with rows, right, and records and whatnot. So different ways of representing relational databases, right? It could be a schema like this, it could be a create statement, or it could be an actual table, right? And then I can ask you, out of those three, right, whether I give you a schema, a table, or a create statement, which one is the equivalent UML diagram? Okay, so we have song, and playlist, and it looks like we have a playlist has a primary key, the song has a primary key, and the playlist has a foreign key. So this is a foreign key that is referencing the primary key on the playlist. So looks like there's a one-to-many relationship between these two, right? So we have a playlist, right, and we have songs, and there's a one-to-many between the two. Okay. Now this says here, select the best UML diagram from below that matches the best equivalent UML diagram. Okay, the best. Okay, so it gives us two of these, right? It gives us two. Notice that neither one of them shows one-to-many. Okay, so they're equally missing something. Okay, so there's nothing makes one better than the other for the one-to-many. Okay, so we'll need to go with something else. What's better one than the other? So let's see what we have here. So the only difference between the two, right? They both have title. They both have title. So let's remove that. They both have title. So that's not the difference. This one has a foreign key referencing this primary key, and this has a primary key over here. Now, the question is, I guess it's a little convoluted here. It says the best equivalent UML diagram, right? So what's the difference between the two? Well, one has primary keys and the other one does not, right? One has keys and the other one doesn't, right? And we have mentioned before that if you talk about pure UML, pure UML doesn't really care how you're going to implement this, right? It doesn't care that you're going to implement it in Java, Python, PHP, C#. It doesn't really care if you're going to implement it in, right? It only cares about the structure of the data. You're describing the structure of the data. This here, the primary keys and foreign keys, that's specific to relational databases, right? You're kind of saying that you're trying to capture here a table, right, that you want to implement in a relational database, right, either in SQL or whatnot. So these are implementation details. They're not really part of the UML class diagram, right? So if we're trying to just stick to UML, right, and that's kind of hinting at here, right? What's the best equivalent UML diagram, right, then we would have to go with this one. This is more pure UML, right? Whereas this one is more, relational database management, right? It's because you might be talking to a system administrator, right, a DBA guy, right, and maybe a non-programmer, and you're trying to explain about how to implement foreign keys and primary keys, but it's not really UML, right? So UML does not care about any of these implementation things. You can add it, sure, you can add it in there only for clarification purposes, depending on who your audience is, right? But that's why this one says, the best. Which one would you choose if you're talking about UML class diagram? Okay, so you choose this one over here. Consider the schema below and the constraint. A playlist may have one or more songs. Okay, this one's also a little bit tricky, right? That's why we're taking a look at this, right? It says a playlist may have one or more songs, right? So this is the same diagram that we had earlier, right? We have a playlist, and we have a song, and you have one to many, right? One playlist can have many songs. Select again, right, the best equivalent UML diagram, right? Meaning you're going to have two UML diagrams that are going to be looked almost identical to each other. You're going to have to scratch your head and says, which one's better, right? And also you need to understand what criteria are you using to choose one versus another, whether your criteria is valid. Okay, so let's see what do we have here. We have a playlist with a one and a many, so that looks promising. What about this one? You have a song. Okay, this one says that the minimum is one. The minimum is one, but it can have any number. Any number. This one says you have a one, so this one's also promising. This one has, okay, so this has the wrong arrowhead. That's the wrong arrowhead and the wrong type of line. So this one's no good. Okay, that's the wrong arrowhead. This one is inheritance. That's inheritance. So again, this is wrong also, right? Okay, so it's between these two. So this is going to be subtle, right? Which one is it? So let's read the text again. The text says, right, a playlist may have one or more. So the one or more kind of points me towards this one over here, one or more. So at least one, or can have any number after that, right? But again, if you read this a little more carefully, it says may have. It may have one or more. Usually may have means that it may not have also, right? So it's a little play of words in there, right? It may not have, right? So it could have one, or it could have many. I don't know how many. It could have zero. Zero is certainly may, right? So again, some of these subtleties on how you read certain English language, right? And how do you translate that, which are requirements, right, into something that you're going to enforce in a relational database or in code or whatnot. And that's one of the toughest things to do in the design phase. When you're interviewing all sorts of people and there are, saying all sorts of things in English, and English is often case, inconsistent. It depends on interpretation and things like that, right? So this kind of that then if you can capture or pick up some of those subtleties, right? So definitely we're going to go with this one, the first one, right? Because this captures the fact that it may not have. I don't really know. It's a very weak relationship, right? This one's a little stronger. That one's a little stronger. At least I know I have a minimum of one, right? So this one's a little stronger, right? But this one doesn't. If this would have said, a playlist has, right? If this would have says has one or more songs, then definitely I would go with this one. right? But because it has the may in front of it, right, it says, well, I don't really know how many. Okay, so I go with the first one. Okay. Okay, so let's go with this one. It says, consider the schema below. The students are enrolled in sections taught by a professor who assigns a grade. Let's see. So students are enrolled in sections taught by a professor who assigns a grade. And we have the schema students. We have the section. So select the best equivalent UML diagram from the choices listed below. Okay, so it looks like so a student. Here's a student, right? And are enrolled in a section. So you have sections, right? And you only have those two. This one has the name of the student. This one has the name of the student, name of the section. And this doesn't seem to be any relationship between the two, right? Notice that neither one has foreign keys or primary keys that are pointing to each other, right? So you know, students are enrolled in sections taught. So it looks like there's some kind of enrollment here, right? That relates the two, that creates some relationship between the two. And in that enrollment, I'm capturing. So are enrolled in sections taught by a professor. Notice that the section doesn't have any information about the professor, or the student doesn't have any information. So perhaps the professor would be part of this new class, and the professor assigns a grade. So presumably I have also a grade here, right? So I have this new class over here that has the professor who taught this and the grade, and somehow it's relating the two. Okay, so it says, select the best equivalent UML diagram from the choices listed below. Okay, so what do we have? So notice that the choices that we have all are offering us this brand new class, right, enrollment, right, that has professor and grade. And so it gives us a couple of choices, right? Do we use this diagram? Do we use this diagram with the funny looking arrow between the student and the name, and then this this dotted line going down? Do we choose that? Or do we choose this enrollment that is clearly a reification, right, with a one-to-many and a many-to-one? Any error there? That doesn't look like any error, right? It looks like this would be a foreign key from on both sides, referencing the section, referencing the student. So that looks okay. That looks right. Okay. This one is almost the same as that one, right? Almost the same between the two. The only difference is that we've flipped the cardinality, and that doesn't look right, right? It doesn't look right that the student has a foreign key pointing to the enrollment. That makes no sense, right? It is the enrollment who should point to the section to student. So definitely not this one. Definitely not that one. Okay. What about this enrollment over here? This enrollment with a many-to-many. Well, I mean, yeah, you could do that. The problem is, notice that the grade is being stored in the student side, and well, that would tell me that I only have one grade for that student, right? And but what we're saying here is that we want to have a grade between a particular section and a student, right? So if a student in a different section, they would get a different grade, right? And if it's a different section, they would get a different grade, right? So definitely this does not allow me to capture this, right? So this does not allow me to capture this. This would have just one single grade for that one student. So this is no good. This is no good. So definitely not this one. So this leaves us just these two, choosing between these two. Which one would you choose? Right? So we know that we discussed the implementing either one of these would be identical in a relational database, right? In the way you would implement either one of these is basically you have a mapping table. Both the mapping table would have two foreign keys pointing to the section and the student. So the implementation in relational database is identical to either one of these, right? The question here is, which one is it more appropriate right? Which one is more appropriate between the two, right? And we said that this with the dotted line over here, right, is part of a more modern UML version 2.0, right? That suggests that that we want to be able to distinguish between these classes that are creating the associations between these two. They're both establishing an association between the two, right? But the difference between the two is that if the association class, the enrollment, right, if the association class has its own fields, then you should go with this more modern documentation, right? Where you use the associate, we call this an association class, right? An association class where we have a dotted line between the two, a line between the two, right? And then dotted lines going down. This one over here, is still okay. Still okay. This is an older version of UML, right? We discussed this when we talked about it in the lecture, right? This is still okay, right? You would oftentimes find this documentation, people using it just fine, right? But it's an older version of UML, and it doesn't stick to the newer standards in UML 2.0, right? But again, you would still find this quite a bit in documentation in there. So again, this is asking, well, which one is best? Which one would be better? So definitely this one. Okay. If we did not have a professor and we did not have a grade, right? Meaning we did not have these fields, these fields, then this would be the better implementation. Okay, because this would be just a mapping table or mapping class saying that student is related to that section, and that's it, right? So if you didn't have these fields, okay, then you would use just a straight mapping table between the two, or mapping class, right, and saying that student is enrolled in that section, and that's all I have to say. I don't have anything else to say about professors and grading or anything like that, right? So either one. Okay, so yeah, so this one. What does UML stand for? Make sure you know your acronyms, right? I don't know that we've used any other acronym other than UML, right? So we're going to go with Unified Modeling Language, right? And it looks like it's listed here twice, here and here. I'll make sure that it only shows up once. Okay, so we'll go with Unified Modeling Language. Match the terms on the left with the best corresponding definition on the right. So yeah, so this question is about the relational algebra, right? In relational algebra, right, we had all these operations, right, that these were, oh, there's a typo here too, right? There's a typo where project appears twice. Sorry about that. Yeah, so it appears twice. That's easy, right? That's good because you're gonna get double the points, right? So anyway, so this was a question about relational algebra, and these were your your one table operations, right? Select, what did select do? That allowed you to retrieve the data from a it filtered the table vertically, right? It selected only a few, right? So this selects a few some rows based on predicate, right? And you would have a drop down here where you would see all the definitions of each one of them, right? And you can select which is the definitions for select. Project, right? Select some fields, right? Meaning it filters horizontally, right? It throws away some fields. You only keep a subset of the fields, but the same rows, right? So it keeps rows, right? And this keeps all fields. Okay. Sorting, it reorders, right? Well, not reorders. It doesn't change the actual orders of the records, but it reorders it, for your viewing, right? For your viewing pleasure, right? But it doesn't actually rearrange the data in the database. Product, right? Does a combination of all the permutations of the records on one of the tables combined with all the records in another table. Okay. Join is a combination of a select and a product, right? You do a product, right? And then you select the ones that make sense, usually by a joining of two fields, right? Say that only where the primary key is equal to this foreign key, right? Then you have a semi join, where you do a join, and you just want to identify, which records in one of the tables have a match with another table, right? But you don't want to bring any records from that other table over, right? You just want to identify and filter, which records from table A have a foreign key that matches a primary key from some other table, but you don't care about any fields or any records. You don't want to bring them over. Right? So that's a semi-join. Anti-join is the opposite of a join. Union is the concatenation of two tables, right? Where you get, or two result sets, right? Where you can grab the results of one query and the other one query, and you put them together. You have to make sure that the fields have the same names, the same data types. Okay. When we talk about outer join, we have left outer join, right outer join, right? Where you bring not only the records that match, right, that have a matching with a foreign key primary key, you also bring some of the records that did not match, right? Either from the left table or the right table, right? Or all of them. You bring everything. Okay. We also again in the same vein of using algebra or relational algebra, right? We're saying consider the following schema: students and departments. What does the following expression do? Okay, so remember some of the symbols, right? Where pi was a project, right? This is project, right? Sigma, that's select. Okay, so this is saying so select, and see this is a predicate. There's a predicate, right? And this is an and. It says retrieve. This is select. The select where right, the department is 10. Department is 10. And the graduation year is 2004. Okay, so basically, it's retrieving all the students from department number 10 that graduated in 2004. Right? And then project is filtering and saying, well, I only want the names of those students. Okay. So the questions were retrieve student names of students enrolled in department A and graduate. Okay, so that looks right. Right. Students names enrolled in or, okay, no or, it's and. Retrieve department names of students enrolled in and graduating. Wait, retrieve department names. No, not department names. No department names. Right. So it's definitely the first one. Here, what's this? This again, following a relational algebra. Right. Given the same two tables, student and department. What does the following query do? Right, so inside of a select, see that? So whatever the output of this is going to be the input of the select. Okay, so what are we doing here? We're saying we're projecting from the student table. We're only filtering and keeping the name property, right? Only the name property. And so basically the select statement is just getting a big result set with that. You only get the name. You only get the name. So then you want to apply this predicate, department ID, but you don't have a department ID field anymore, right? It's gone because the project removed it, right? So this returns just an empty query, right? So the query is meaningless, therefore the query returns nothing. So yeah, so that's that one. This one says, based on the airline database, right? So the airline database, so it's this one. So it's this one over here. It says draw or write SQL query to calculate how many reservations. So we need to count reservations. Okay, meaning we have to do a count and then reservation. Yes, were made with the Qatar Airways flights for a cost higher than the average cost of all Qatar reservations. Right. Note that the cost of the reservation is the sum of the price of all the tickets in that reservation. Only list the total number of reservations, rename the calculated fields, number again. Okay, so you're not going to be asked to write queries. Okay. Where you can actually type, the select and whatnot. Instead, right, you would get the similar questions as before, right? We say, well, we would give you a select statement with groupings and nested views and blah blah blah, right? And then we say, well, which one of this is matches, right? Which one is resolves that particular answer? Okay. All right, I'm actually going to do this for you, and I'll provide it. Although I've ran out of time, I'm going to fill this up, and then I'll share it with the rest of the class. Okay. All right. We reach the time. Any questions? Was this helpful? Yes. No. Okay. All right. If you have any questions, let me know. Let me know, and then we can talk about it on Piazza. I have another class right now starting at in a few minutes. Right, and I'm going to do exactly what I did now. I'm just going to do it all over again. All right. All right. Thank you, everyone. Bye.
Thanks, Professor.
Take care. Bye.